Hello everyone, my name is Nikolay Igotti, and today we'll have two related webinars associated with Kotlin 1.3 release. One will cover Kotlin native, and another one will cover Kotlin multiplatform. So in this webinar, I'll try to explain the technology behind the Kotlin native, show small demo, and we'll talk a little bit about technologies. Okay. So what is the story and challenges behind Kotlin native? Originally, Kotlin was a JVM-only language, and as such, it was only suitable for JVM ecosystem languages. JVM is a pretty widespread platform. However, it's not only there. On small devices, on mobile devices, on microservices, on embedded systems, Java may not be present. So we decided to fill this gap and provide functionality of Kotlin programming on native platform. Another important goal of Kotlin native as a platform was ability to interop with non-managed ecosystems. So, for example, in case of JVM, interoperability is provided using JNI stubs, and they have to be written manually, and it's generally error-prone and not very pleasant process. So to call into the native world, you have to pay both performance penalty and development comfort penalty. So we decided with native to provide an ecosystem which gives a traditional Kotlin look and feel, where you can write in nice language with all your common standard library patterns we'll like and use, but on native languages, and also use the native libraries as easy as it present on a JVM platform. So the goal was pretty ambitious, to provide as comfortable interoperability as with as in JVM ecosystem. So we tried to build on existing ecosystem, and it's on purpose design goal of the whole Kotlin project and Kotlin native project in particular. What does it mean? So now software engineering is a pretty mature area, and so there are many existing ecosystems, and there are many developers, many jobs, many technology, lot of intellectual property laying in the particular ecosystem. So once you appear in a market with a new programming language and programming technology, you have a very strong dilemma. You either need to build completely new ecosystem from scratch, or you need to interop with existing systems. And we with Kotlin, we generally took a second approach, because we believe that building ecosystems is very time consuming, very resource consuming, and sometimes is not valuable for our end users. So what instead we trying to do is provide maximum comfort for our developers. So it means maximum code reuse, maximum expertise reuse, maximum existing libraries reuse, and as we are Kotlin ecosystem, we also want give people who used to use who knows and likes Kotlin the ability to enter into the new world, into new ecosystem where the skills before couldn't be applied because they didn't know the language, they didn't know the libraries, and so we build a Kotlin native on a promise of integration with existing ecosystems, with the same set of tools provided by other Kotlin flavors. As we build on on existing ecosystem, we also build using existing technology. And here there are logos of most popular technologies used inside Kotlin native stack. So we of course use Kotlin. It's we both reuse language frontend, and we wrote the compiler itself in Kotlin JVM, so it means we use Kotlin a lot internally for development. We run on a JVM, so we use Java, of course, and we use IntelliJ platform for the tooling support. So we also built here on existing platforms. And we use Gradle as a project project description language, so that once you build you describe the relation in your sources, which sources are for which platform, and so on. And we also use Objective-C and Swift as very important languages for to interop with. And of course, we use LLVM for code generation, for producing intermediate language called LLVM bitcode, and for subsequent code generation of the native binaries. And we of course need to do very good in interoperability front, as I described, as we don't try to build a complete, absolutely self-contained ecosystem in Kotlin, and in Kotlin native specifically. Instead, we need to integrate into the existing world. And existing world is usually libraries, and libraries are written in languages which are different for different platforms. The most popular languages for relevant platforms, relevant for us platforms, are the following. It's C for native development on Linux, Windows, and other similar platform. Objective-C and Swift for development on iOS and macOS ecosystem. There is a popular demand for C++, but here we decided that interoperability with C++, while being a noble goal and like very hard technical problem, it's not something we want to invest into at the moment. So we provide interoperability with arbitrary library. So unlike Java, for example, or many other older languages, which to interop with external world, or Python or JavaScript, you need to write custom code wrapping the particular library and adapt it for using with a particular API. Kotlin native is different. It connects the language and external libraries using automated tool. We call it interoperability tool, and we're able to analyze the headers or other metadata describing libraries, and automatically produce binding into the Kotlin world. And as this tool is automatic, it means it scales well. So we were able to provide bindings to platform APIs such as POSIX, OpenGL, Windows, Win32, Foundation, AppKit, and similar toolkit. We now can cover pretty much arbitrary C or Objective-C library available, and we do that for very popular libraries which always exist in the platform. So it means you can use those libraries from Kotlin as easy as you could use JVM from Kotlin JVM. So JVM code, JVM objects. But we also understand that creating new ecosystem is not only creating a set of smart or super optimizing compilers or whatever. We also understand that the key moment is creating tooling, and this tooling must be useful. So we use Gradle as a mechanism of description of project and the mechanism of building the final programs. JetBrains IDE platform called IDEA as a platform for tooling in integrated development environments. And we also include compilers from other languages, technically from C or from Objective-C to Kotlin to provide the seamless interoperability I was talking about. So this means that our solution is trying to be as useful and as easy and comfortable to use as possible. And what I will try to do now is a pretty short leaf coding demo. So first, a little bit of configuration. What I have here is a pretty standard IntelliJ IDEA. So it's like a regular IntelliJ IDEA Ultimate with Kotlin plugin. It's 1 through 11, and it's all stock. It's not modified. It's very easy to install on any machine. And what we'll do here is we'll create a new native project. So we'll create a new project. We'll select the language being Kotlin. Here the Kotlin native. So we'll create a standalone native binary. Let's call it webinar 5. Oh, no. Webinar 5. Okay, finish. Okay, new window. And this new project wizard will create a project structure. This project structure consists of the build script. It's Gradle build script, which describe my project. Here it says that it's a multi-platform project. We use Kotlin multi-platform plugin. We select a target being macOS x64. That's my machine, and in a source set we say that my source set is for main, macOS main, and macOS test for my tests. So the code created by wizard, of course, is very straightforward. It just has a main method which calls hello method. So let's start this code. Tasks, other, run program. You see the task was this task was created for me by new platform wizard. Okay, while we compile, I'll explain what we're going to do next. So next we'll create a macOS core application which will render window, and when clicking on button, doing some action, changing the state of the window. We'll start with very simple code. I'll copy paste just to not type in live demo. Save your in mind term. So you see, I passed it code which has function run up, and it's not yet defined, so I will define it, and it also exports the function from POSIX library. Here I show it. This is a function which exit from the program. I just show that it's available and known to ID, so it knows its signature. It knows that it could be called. So the next step. Now let's create an actual application. So as we use Cocoa framework, we use create get a shared application instance, and then just see ID automatically inserts additional inputs here, and now I have very basic application. It doesn't do anything. However, it already creates a graphical application. So I can compile it and eventually can run it. The compilation speed is not perfect, but due to existence of tooling, it's pretty much tolerable when you develop. So while it's compiling, what we're going to do next is create a very simple graphical interface to this application. Sorry. We create an application delegate which defines the behavior of this particular application, and say something like when application will finish launching, we'll do we'll render a window, and so far we'll remove that. Just render an empty window, and once we click on certain state in window, we will delegate a notification about the state change to controller. Okay. So not yet. Oh. Here we get a complete application. Let's compile it. So now this application will create a simple window without the content, however, with the top level window. And while it compiles and run, now it shall compile, and as we see with ID, it verifies that that all API checks are correct, and then we see an empty window. And once I click the cross button, it goes here, and application close. And now just for the fun of it, I'll add a little bit more functionality. Namely, once we click the button, okay, already had that logic. So on click, we'll select we change the text of the text field created here. Where is this text? Oops, content text. Okay. Sorry. So we select content text. Okay, so as usual with demos, something sometimes go wrong. Here, for example, we just okay, so I just removed it from a place where it shouldn't be. Okay, so now I added the content text, and also I will add two buttons, which and the text field into the window content. Oops. Okay. Now the program is correct again. So we see no red signs. We'll compile it, and in the meantime, I'd like to show you that all those APIs are recognized by ID. And for example, if I want to add I'll show you how it works, and then we'll make a small change to it. So, okay. So we created an application, and once we click, the text changes and the color changes. And now let's imagine we don't like yellow color. We want to make other color. So we want, for example, blue color. You see the ID suggests me that in NSColor API there are blue color, and we can use it. We can start compilation again, and and hopefully we'll see the blue color once I will click the button. So the story which I want. Okay, the compilation time is something we actually work on improving. Hold on. So click. See the blue color instead of yellow color, which used to be here before. Okay, so we finished with the demo, and let's go back to the presentation. As I've shown you, we can do a lot. In less than 10 minutes, we created a relatively functional UI application in less than 100 lines, and people who are familiar with Kotlin probably wasn't very much misunderstanding what's going on in the code. The same shall be with people who are familiar with macOS development and not familiar with Kotlin. So this is the current state of things. As I said, it's already a released tools. It's already there, so you can go and try immediately. And same is true for Windows platform. You can write the similar platform program on Win32 platform, for example. So what about the future? What we're gonna do next? First, the native backend is in better quality at the moment, which means we're relatively stable. However, there are API changes, there are binary compatibility changes, there are not very unlikely, although not very likely, dramatic source incompatibilities, which we'll try to avoid at all costs, but still. So we want to get out of the beta and provide more compatibility guarantees, better compilation performance, better runtime performance, a lot of things actually. Second is, of course, better tooling, because you probably noticed that in tooling I've shown you there was no debugger functionality. So there is basic native debugger functionality in CLion. However, its quality could be improved, and this is another area where we plan to focus on in upcoming releases. Also, I would like to emphasize that Kotlin native will evolve along with the rest of Kotlin ecosystem. In the context of Kotlin multi-platform paradigm, which will be covered in the second part of this webinar, we will create the features which will span across multiple backends, so not only cover the native but also may cover other backends, and we there could be language changes, there could be tooling changes, there could be Kotlin Gradle plugin changes. So there are many things which may get improved in the future. And to shape this input, because there are many things that could be done, but we do need your input. We need an input on where you believe that native shall evolve to. So provide us feedback through Slack, through through some issue tracking, either UTrack or GitHub, whatever you like, and we'll try to use your input to actually make changes in the platform. Okay, so now it's time for questions. Okay. Okay, so first question is how to debug native targets on IntelliJ. Does it support instant debugging? The answer is to debug native applications. Currently, it's required to use CLion because IntelliJ, neither community nor Ultimate include native debugger functionality, so it's not in the platform yet. And in CLion, debugger functionality works for many cases, but there are things to be improved, and we are working on that pretty actively. Does it support instant debugging? I do not think that we support instant debugging, and moreover, I think that forms of native debugging in unmanaged runtimes are usually very limited due to the nature of native compilation, which requires pretty deep pipeline, and the lack of managed runtime where you can unload classes and things like that. So the next question: what package manager will be used in Kotlin native? As I mentioned in my slides, we use the context of the outer ecosystem, and it relies to package management as well. So, for example, if you check out the samples of Kotlin native, you'll see that in a documentation which uses external library. For example, our video player sample. You see that for different platforms, we suggest using different package management. If we're talking about multi-platform and Kotlin libraries redistribution, then here we rely upon Maven and Maven artifacts and Gradle metadata as a mechanism for distribution of packages. What general performance improvements will be included in future Kotlin native releases? There are many definitions of performance, first of all. So generally, performance for different languages, for different runtimes, for different situations may mean pretty different things. So, for example, in live demo, which I shown you, you see that generally compilation of application producing was pretty slow, but the startup of application itself was pretty fast. It's and runtime for typical UI-driven application is already okay. But we understand that there are other problems. mostly related to manipulation to heavy, complicated object graphs, where there could be improvements. So our current performance focus are around compilation performance, around memory management performance improvements, and around compiler optimizations, which can be shared across multiple Kotlin backends and can lead to more efficient code generation. Okay, the next question. Will there be better support for using other libraries with Kotlin native? It really depends on in which language the other libraries are written in. However, the general vision is we hope that for Kotlin libraries, people will develop multi-platform libraries, which could be distributed through Gradle and can be used as regular Maven artifacts. So, and generally to use third-party libraries, you need to if it's a native library, is like written in C, for example, or in Objective-C, you need to wrap them. And if it's Kotlin library, then there should be not a big deal. Okay, next question. Is there anything in Kotlin native that will make it easier to handle C libraries that heavily use reference counting? I don't think there is anything too Kotlin native specific for that. Kotlin itself is pretty powerful language. So due to inline functions, for example, you can have pretty cheap functions which takes it also is functional language. So it means you can take functions which takes other function and execute them in a certain context. So so for example, you can combine reference counting with execution in certain context. Next question. Will any tool libraries be made available for collecting and extracting metadata from klibs? Okay, for a little bit of a context, klibs are Kotlin native library format, which encapsulates Kotlin metadata along with the bitcode at the moment, and is current artifact for artifact format for Kotlin native libraries. As a cross Kotlin team project effort, we currently working on unification of klib format and using it across other backends. So we hope that some tools will appear as a result of this activity. And at the moment, you can use the klib tool, command line tool included into Kotlin native distributable. Any plans for cross-platform development compilation, or at least code completion? Well, it's a nice question because the answer is we're already here. So we can perform cross-platform. So, for example, although in my live coding demo I was coding on Mac for macOS, however, if I would select different templates in new project wizard and created a project where I would target iOS, then I would get completion for iOS. So we don't need no plans. We're already there. The little bit tricky part, although it's not all host target pairs are available. For example, you can compile for macOS from Linux or Windows host, or for Windows from Linux host. We decided that there are traditional hosting environment for certain target platforms, so we supported only those combinations. but it's not it's not fundamental limitation. It's mostly a limitation of native tools we eventually invoke. Okay, next question. Are there libraries available for generating Kotlin source code via Kotlin native? I think to generate Kotlin source code, you can use pretty much anything. Kotlin source code is a text, so and whole Kotlin standard library, including Kotlin text and even regular expression engine and whatever you may imagine is available. So I'm not sure if a special if special library is available, but of course if someone will write it, it would be amazing. Okay, the next question. Keter is the perfect multi-platform solution for HTTP REST client interaction. But what about native gRPC? Yes, it's possible, and once again, if someone would write, or even more correct, to generate binding to gRPC C library, then you'll get it. Any plans to support TVOs in the near future? Not immediately, because it would require us to generate the whole program in a bitcode format. Although at the moment we generate almost everything in a bitcode, but the small piece of libffi required for native interop. Possible overhead on garbage collecting and reference counting mechanism algorithms in Kotlin native. Yes, of course, any memory management mechanism introduces overhead. They just the cost is different. For example, classical tracing collector usually puts an overhead in form of pauses, and in runtime it could be very cheap. And reference counter, usually the cost of memory manager is spread across the runtime of application. And for example, for graphical and user interacting application, I believe the second approach is more suitable. Is there going to be an option to turn off the cyclic collector GC and use weak references instead? It's technically possible to compile Kotlin native runtime without cyclic collector GC. Just a single define need to be turned off. So it's not too problematic. But I'm not sure how useful it will be. And yes, weak references already supported in Kotlin native runtime. Possibilities of resource acquisition, as initialization and manual memory management without automatic GC with reference counter in Kotlin native. How to use throw and save pointer reference in Kotlin native. Fortunately, for Kotliners, classical RAI is not actually needed in Kotlin due to the presence of inline function. If you want to do something, to execute something and call something on exit from scope, then you just pass whatever was your scope to some function which will call whatever you need at the exit. And to use row pointers, Kotlin C-interop has an object called C-pointer, which is essentially a row C-pointer with the same semantic as in C. Are there any plans hope to improve object lifecycle observability in Kotlin native, specifically when interfacing with Objective-C? There are no specific plans. However, we could discuss it if you will open your track or GitHub issue. Possibilities of memory safety and thread safety in Kotlin native, control immutability of pointers and references, strong weak references, automated reference counter, reference types, and value types. Well, generally, we believe that we believe a lot in memory and thread safety in Kotlin native. That's why we have pretty non-trivial Kotlin concurrency model, which is related to memory model, which also implies certain immutability consequences. But it's a very big topic which I couldn't cover during this short Q&A session. Are there any plans for adjusting the concurrency model? Yes, there are plans not for adjusting, but for considering less strict option of compilation. We believe that current concurrency model has its value for certain people and use cases, but there are possibilities that more relaxed model would make sense for other people. Will Kitra server mode will be in Kotlin native, or what used at the moment? Kitra server is not currently being worked on for native. However, there are C libraries, for example, micro HTTPD or other small HTTP servers which could work as HTTP server in native. Can there be conflict between different third-party libraries written in Kotlin native? For example, Company A write analytics, B it's Company C integrate libraries from A and B together. There should be no problem as long as they use the same version of Kotlin, because current Kotlin native has pretty weak cross-version compatibility. Other than that, it should be not a big deal. I understand that the last question. I understand that JetBrains will be evaluating compiler-based support for Kotlin native code coverage, but I'm wondering if using some compiler flag has any merits as a basic for building a quick and clean code coverage tool. Well, we wouldn't recommend this flag because it was essentially developed for the purpose of debugging information generator debugging so that we could generate more correct debugging info, and we don't believe it's a tool to be used externally or something we shall provide or recommend for outside usage. Okay, so thanks everybody, and we'll have very short, like 3-4 minutes break, and I'll be back with you at 6:45 for MPP session. Thank you and goodbye. Okay, welcome back everyone. We'll continue our Kotlin 1.3 webinar, and this part will be dedicated to Kotlin multi-platform. So Kotlin MPP is an abbreviation for Kotlin multi-platform programming, and in this part we'll discuss challenges and design decision behind multi-platform programming approach in Kotlin, how we did language support, how we supported in compiler backends, and how it's supported in tooling such as ID and Gradle, and discuss availability. Okay, so the multi-platform programming is pretty old problem, let's say. There are different approaches. For example, the Java has a very well-known motto: write once, run anywhere, which essentially transformed into write once, debug anywhere. And that's pretty typical that during development of software systems, people realized the economical benefits of multi-platform solutions, where you can write code once and get it executed on a very different computer systems. But also we realized that sometimes the tools for cross-platform and multi-platform development, such as Java, may be not perfect. Because the common tendency is to abstract out the platform into a set of common APIs, common functionalities, and force every user of certain technology or platform rely exclusively, or almost exclusively, on a mechanism provided by the platform anywhere, and blocking and access to whatever is available on the platform itself. But the platforms are different. We need to do different things with them, and we may want to do this in the same application, targeting different platform. So it may be a hard problem, but also it's something worth doing, because for example, if you have an application and need to write it once, then you probably may need to run it more like you may need to avoid writing it second or third time for other platforms. So some form of code sharing between platforms, of course, is very desirable. And moreover, it would be very nice if tooling would help with multi-platform programming. So, what is very important part of multi-platform program, as we consider it at JetBrains, is availability to whatever the platform has, to every API provided by the platform to program if needed. Of course, it may be not the case, and frameworks like React Native, Unity, even Java, they generally abstract out whatever is available on a concrete platform into some intermediate layer, which is used by programs. It's so-called porting layer, and programs are written in porting layer, and as a result, they are portable as long as porting layer is implemented the same way on all platforms. This is generally pretty good approach, but it's limited in case of very rich API underlying in platform. So, for example, if we're talking about libc-style APIs, then of course they could be easily abstracted out. But if we talk about API of complexity of POSIX or Win32 or Apple AppKit or Foundation, you'll find literally thousands and tens of thousands of functions, definitions, methods, and they all need it. They're required for some part and for some programs to actually feel truly native on a particular platform. And moreover, platform evolve, and it means they provide a new functionality. And as long as new functionality appears, usually vendor provides functionality in its platform APIs to use this functionality, but it doesn't mean that the vendor of porting layer updated the porting layer to reflect this functionality. So if we live in such a paradigm, then why don't we share what need to be shared, but keep specific what shall be specific. And as Kotlin is a programming language and programming ecosystem, but we start with a language. The language construct for multi-platform programming is expect and actual keyword. So expect generally describes the outline of what's available in your application, and it's common across multiple targets. And actual defines the actual objects, functions, constants, type aliases, whatever, which are concrete on a given platform. And tooling knows about difference between expect and actual, and while the compiler itself always use actual declaration for given instance of code generation, the tooling in analysis uses expect declaration to understand that okay, this code would be the same if run or compiled against Kotlin JVM, Kotlin native, and Kotlin JS, because it only uses a common part of Kotlin standard library. Okay, so, and then I know that it code is runnable on all those three platforms, and we can resolve such a code once if we're talking about integrated development environment, even if they are targeting multiple different platforms. And we provide the support for tooling, which knows about those language keyword and provides required navigation. So, if we take a look at a compilation paradigm behind MPP, it's a cooperation of different Kotlin backends. As I mentioned, Kotlin got three backends: JVM backend, JavaScript backend, and native backend. And JVM is traditionally used for server Kotlin workloads, and Android managed execution, so execution inside of a virtual machine. Kotlin JS used for execution wherever JavaScript is available. It's typically a browser or Node.js environments. And native could be used for iOS or Android native development. So yes, with native you can compile to Android and produce so-called native activities, which are pure native applications for Android, which doesn't require the virtual machine to execute it. Another important target for native is desktop operating systems such as Linux, Windows, macOS for development graphical user interface or command line interface applications. and of course embedded market where lack of embedded lack of virtual machines usually means that managed flavors of Kotlin cannot run. So together, those three very different backends compiling to a very different ecosystem provide the very wide reach of Kotlin multiplatform. So imagine you have certain application which you want to run on your mainframe. There is no mainframe backend for Kotlin native. I'm not sure about the JavaScript virtual machines, but there is a JVM virtual machine. So you decide, okay, I'll take Kotlin JVM backend, and using my knowledge of Kotlin and Kotlin standard library, I compile to JVM backend and get it executed wherever I like. So generally, it means that for Kotlin programmers, different ecosystem became more transparent than for programmers in many other languages. It's typical situation where the language is tightly bound to an ecosystem, or even forms ecosystem, as in case of Java and JVM ecosystem. And Kotlin provides you a way to go out from the ecosystem which you don't like, or you don't get a good enough job or whatever, and go to the other ecosystem, for example, mobile development, microservices development, whatever you like. So that's what flexibility of backends gives to Kotlin programmers. And if we think about a single project, then of course we need to be able to share the code. As I mentioned, only this code which indeed shall be shared, not all code, but some of the code. And of course we need to be able to do refactorings, because to refactor certain big program, for example, to rename a class or rename a function, sometimes people are really reluctant to do that, and it happens this way because they don't fully understand the consequences of their rename. They're afraid that people from sibling team will come and say, "Oh, hey, why did you broke my build?" So people just avoid doing refactoring, and that's not very good. And so, if we can actually share the code between multiple programs, multiple platforms, I mean, and multiple targets, then as long as they describe it in the same project description using Gradle, IDE can read this description and understand what files your project consists of, even for the targets for which you're not really developing at the moment. So when you compile, you describe whatever need to be used using a presets, and so IDE sees all the presets and can build a project model. And using project model, it can produce global refactorings of all your projects, both server side, client side, mobile, whatever. And also it as it has this knowledge, and could provide you navigation to platform-specific definitions, so that you can not only see, okay, this is how my iOS application use this class, but also I can figure out how iOS use this class, or how web client uses this class, which gives a significantly better view on project structure in general to the programmer. and of course it gives more control and so better development experience. So it's all good and nice theory, but once again, is it actually available? And fortunately, our answer is yes. All what I'm talking about is available now. So since Kotlin 1.3.0, all three backends are shipped with Kotlin plugin. So as long as you use Kotlin Multiplatform plugin, you can use Kotlin JVM, Kotlin JS, or Kotlin native backends. They all share the same common part of standard library. It means the Kotlin standard library is split in two parts. One is backend specific, so that there are certain extensions specific for JVM, certain extensions specific for JavaScript, and certain extensions specific for native. But there is a pretty rich common subset which is shared between multiple backends. And moreover, IDE fully supports multi-platform programming. So you can navigate to definition from common code to actual definition and back. So everything is supported here. And JetBrains provide a multi-platform version of its popular libraries such as coroutines, serialization, and the HTTP client in Ktor. So it's there. Okay, so far it sounds like a salesman talk. I'm telling you everything is great, everything is working, but well, engineers will know that the more complex the technology is, of course, the more potential and actual limitations exist. So, is everything that good with MPP? It's not absolutely brilliant at the moment. It's good enough for use, but there are problems, and there are several areas of problems with MPP, such as projects with very complex layout. We call them multi-tiered projects. They are not yet supported by IDE, so that it couldn't navigate properly there. Compiler compilation performance and sometimes runtime performance, especially for native targets, which is in beta, and so it's kind of expected, is not superior, and generally native also got some interoperability limitations. For example, complex, very complex inheritance chains between Objective-C, Swift, and Kotlin are not supported. You can inherit from Kotlin to Objective-C and then extend this class in Objective-C again, and so on. So there are certain limitations which we find tolerable for practical use cases, and we still working on improving those. But as with native, we really love to hear your feedback, because sometimes we may not know what's very important for people. So now let's proceed to multi-platform programming questions. Just a second. Okay. Will JetBrains create Kotlin native or Kotlin multi-platform wrappers for popular libraries, such as, for example, MongoDB driver by itself, or we need to wait vendors or community? Generally, if we talk about Kotlin native, and if there are existing C or Objective-C libraries, which I'm pretty sure they do exist, for in case of MongoDB, then you don't need to wait too much. You can just interop with those and call them from your Kotlin program now. However, if what you really want to achieve is a Java-style multi-platform where you have exactly the same code, which works with I don't know, with JDBC driver on Java and with some C driver on native, then of course someone have to develop those, and here our suggestion is to put some initiative in here, and if you believe that there is something to be done, try to do it yourself. We cannot cover all library needs. Our library team is very busy actually doing even libraries they already got. So hopefully I answered that question. What's the next multi-platform library planned? I'm not actually the person who leads the library team, so I couldn't give this answer to be 100% correct. However, as far as I heard, there are certain evaluation in area of date time and file I/O. Okay, so seems no more MPP question, and okay, I probably answer few native questions as well. Is there a plan to add struct value type? I have Kotlin native library, but I need to return struct for performance in Swift. Well, usually it may happen that using something for performance need preliminary evaluation. Because, for example, always when you want to return a struct, instead you can pass a pointer to pre-allocated struct and fill it on the caller side. So answer to that question, if I'll take it verbatim, is we don't have a plan to add structs in like in short-term Kotlin native or Kotlin releases. But in the longer term, it will be something, some decision to be made Kotlin-wide, not only on native. Any plans to support x86 for Android NDK? We just didn't have enough demand for Android NDK in general, so so we didn't plan to support it. However, if there will be sufficient demand, why not? Are you planning to prepare more samples with concurrency model? It's hard to use Objective-C or Swift concurrency handles with Kotlin native. Once again, most of our development, where it comes to like concrete code, concrete samples, is community driven. So, for example, someone opens an issue and say, "Okay, I cannot do this. Please help." And then we discuss, and if it's frequent enough, then we create a sample. So please speak up and explain your situation on some issue tracker, and we'll try to help you. Is it possible in the future to have hot reload during mobile development, like Flutter? Well, Kotlin native is ahead of time compiler. Flutter has Dart inside and Dart VM inside. So for managed runtime, it's way easier to perform hot reload and partial computations. However, due to multi-platform nature of Kotlin, it may be possible to implement something like that for other backends. And if your code is multi-platform, then some hot reload could be used from other MPP backends. Will JetBrains work together with Google to make Kotlin available for Flutter Fuchsia? I'm sorry, I cannot comment on this particular question. What is the ETA for Apple Bitcode support? Essentially, there are two mechanisms for using Bitcode in Apple code. First one is to just mark binaries as compatible with the Bitcode. That's already supported. So it means even if your framework is compiled with Bitcode, you can still link it with the Kotlin native framework because it contains needed marker. Just use X embed Bitcode or embed Bitcode marker compiler switches. But if we're talking about the real Bitcode embedding, like CLang does when it includes into executable files not only and the machine code itself, but also the Bitcode. Then we're not yet 100% sure that this is a feature which will be developed anytime soon, unless we'll get a very serious motivation. For example, Apple will refuse to accept a framework without such support in App Store, but I doubt so. Okay. So, seems we answered all the questions. So, thanks a lot, everybody. If you have any further question about Kotlin, Kotlin native, Kotlin multi-platform, feel free to visit kotlinlang.org or our Slack. Ask question. We generally pretty open and friendly, so come by. Okay. So thanks everybody. Bye bye.